I will walk you through a fascinating method for calculating the sum of remainders when dividing sequential numbers. Here's how it works. Start with the sequence of numbers from n to r. For example, if n equals to 10, the sequence is 10 to 1. Next, choose a denominator m, which can be any number except 0, since division by 0 is undefined. For instance, let's take m equals to 3. Now divide each number in the sequence by m and note the remainder. For example, 10 over 3 equals to 3 with the remainder of 1. 9 over 3 equals to 3 with the remainder of 0, and so on for the rest of the sequences. Finally, sum up all the remainders to get the total. This process is a simple and logical way to practice modular arithmetic and improve mental math skills.
Pairwise sum and divide calculates the value for all dictings pair in an array. For each pair ij where I greater than j, we compute for ai plus aj over ai into aj and sum up the results. Example for array 151, the pairs are for 15 flow 1 plus 5 over 1 into 5 equal 1. For 11 flow 1 plus 1 over 1 into 1 equal 2. For 15 flow 1 plus 5 over 1 into 5 equal 1. The total sum is 1 plus 2 plus 1 equal 4. This method is efficient for arrays up to size 200,000.
This explanation addresses the calculation of a power summation problem where the formula is S equal 1 to power n plus 2 to power n plus 3 to power n plus k to power n. With k equal 5 and n equal 2, the solution proceeds as follows. Calculate each power. Compute 1 square, 2 square, 3 square, 4 square, 5 square, resulting in 1, 4, 9, 16 and 25. Modulo operation. Each computed power is taken modulo 100. The results remain 1, 4, 9, 16 and 25 since they are all less than 100. Summation. At the modulo result, 1 plus 4 plus 9 plus 16 plus 25 equal to 55. Final output. Since only the last two digits of S are needed, 55 mod 100 equal to 55. The final result of the calculation is S equal to 55.
Today I'll be talking about the scalar problem. To begin with, the sequence length is determined by 2n plus 2, with n being a natural number. The first two numbers of the sequence are defined by a0 equals 0 and a1 equals c, with subsequent terms calculated as ai plus 2 equals ai plus 1 plus ai modulo m, where m should be greater than 0. The I shown is the list of natural numbers in the range between greater than or equal to 0 and less than 2n. And modulo m means taking the results of ai plus 2 equals ai plus 1 plus ai, dividing it with m, and then taking its remainder as shown in the example. From this sequence, pairs of consecutive terms form vectors such as v1 equals a2, a3, v2 equals a4, a5, and so on. Different combinations of pairs of vectors are made. We then compute the scalar product for all vector pairs using the formula x1.x2 plus y1.y2 modulo m, and store the results in a set. The final output is the count of distinct scalar product values in this set.
Now let's move on to the problem 5 on summing the k in series. First, let's calculate the value of each term using the equation Tn equals nk. Then add the values of each term, which is given by Sn. Finally, let's apply the modulo function. To understand this calculation better, let's calculate Sn for k equals 3 and n equals 5. First, we calculate each term from n equals 1 to n equals 5 using the equation Tn equals nk. As you can see, we have got T1 equals 1, T2 equals 8, likewise up to T5. Then we add all the terms and get the Sn, which is 225 in this case. Finally, we apply the modulo function, and as you can see, the result remains the same, which is 225. This is because 225 is less than 10 to the power 9 plus 7. To understand about the modulo operation better, let's take a larger value. In this case, we have taken Sn equals 10 to the power 9 plus 61. As you can see, the answer we got was 61. That's because when Sn is divided by 10 to the power 9 plus 7, which gives us a remainder of 61. In the modulo operation, the remainder gives us a final answer, which is restricted to a certain range.
Let's break down the problem fun with series step by step. To this, we use Fibonacci-like series for G as here. Next, we should look about the S1 and S2. S1 means the sum includes only positive coefficients where the modulo is 10 to the power 9 plus 7. S2 means the sum includes the absolute values negative coefficients where the modulo is 10 to the power 9 plus 7. And next, we should calculate the coefficient Ci for each P. For p equals 1, these coefficients are like this, and the s1 value will be 1 and s2 value will be 2. For p equals 2, the final s1 value will be 2 and s2 will be 4. And next, we should compare s1 and s2 for each p values. For p equals to 1, s1 will be smaller than s2. And again, p equals to 2, s1 also will be smaller than s2. And the next, the count results are like this here. For the next step, we should calculate S using the given formula, where U in the formula indicates the starting index of the product, and V in the formula indicate the ending index of the product, and G in the formula the sequence of number which was from the earlier Fibonacci sequence in the step 1. Next, we should take U equals to 2 and V is equal to 2, and the value of G2 also will be 1. And final output will be S equals to 1 squared and 1. Thank you.
The circle summation problem involves n children in a circle, where each child updates their number by adding the number of their left and right neighbors into their own. This process is repeated for m rounds. So, in order to solve this problem, we can use the n into 1 matrix, where n is the number of students in the circular array. Matrix B is introduced to depict the influence of the number of a child. Here 1 indicates influence between players, where 0 indicates no influence. If we take the first row of matrix B as an example, it shows the influence on the first child from the second and last player in the circle. Likewise, the matrix is updated for the rest of the children in the array. So, a generalized formula can be obtained using matrix exponentiation, where the transformations are represented as a matrix that multiplies with the array. After calculating the final numbers for all n starting children, take modulo 10 to the power 9 plus 7 to handle large values.
In this problem, we aim to evaluate the 2 by 2 matrix to determine its possible configuration and solution under modulo. The matrix is initialized with its top left element fixed as 0, leaving 3 elements and which can each take values of 0 or 1. This results in 8 unique matrix configurations. For each configuration, Gaussian elimination is applied modulo to find the rank of the matrix. The number of solutions for the corresponding system of equations is then computed using where is the size of the matrix and is its rank. After analyzing all configurations, we find that none yield exactly 0 solutions. This demonstrates that under the given conditions, no valid configuration of the matrix result in a system with no solutions. This approach can be generalized to similar matrix problems.
This problem is about solving questions using a special calculation for x over log. I'll explain the process step by step. We are given a list of numbers and some questions. Each question asks us to calculate something using their values a, p, and r to find the answer. We use the XOR operation, which is way to combine numbers. First, for each question, we pick numbers for a list based on p and r. These numbers are our focus. Next, we combine these numbers in pairs and use the XOR operation with k. This operation is like a special type addition used in programming. After we do the XOR for all pairs, we get down the results to get one total number. Sometimes the total can be too big, so we divide a large number and take the remainder. This gives us a smaller final result. To solve these questions, we focus on the range of numbers, combine them using XOR. If the results, if they make the number smaller. That's it.
I'm going to explain about how to solve the rational sum problem by using example. As you can see this problem, the main thing we have to understand what are the px and qx. And after that, we have to solve this function into the rational number. Let's take the easiest one. So in this question, m is going to 2, a is going to 0 and 1, b is going to 1, which means a0 is 0, a1 is 1, b0 is 1. Like that, we have to prepare the px and qx. Now we simplify this function into this. Now the question is how to find the value, and it should be a rational number. After that, we have to make it like this one. So by the way, we have to find the fx. After the finding fx, we have to list those values to find the pattern. Now you can see the pattern f1 minus f2, f1, f2 minus f2, like that. Those are cancelling. The remaining thing is fn minus f0. Those are the remaining thing. So now let's equal to n value to the infinity, and this whole thing goes to 0 and the remaining answer is 1.